Okay, so I'm starting with the section B of question 3. Here we are supposed to prove that A steric B is a subset of A union B. So how I do, I take an element X which belongs to this set on the left side, and I replace this A steric B with this, and this particular thing is equal to this thing based on the symmetric difference property of sets. You can write that A steric B is equal to A difference B union B difference A. So by doing this, I end up with a new scenario. I have a union of two sets, which says that, and my point X belongs to the union of these two sets, which means X either belongs to A minus B or B minus A. You can imagine it by visualize this by this. Let's say this is this set, which is a union of two sets, and let's say this is my A minus B, and this is my B minus A, and so this X must belong to any of them. Like this can be here or this can be here. It cannot exist in the both of these sets. The only scenario is if it is a common point between these two. So I say that it should belong to either of them, any one of them. So by moving forward, I see that A minus B indicates that the particular point in A should not belong in B. And same, B minus A say that if there is a number in B, it should not belongs to A. So we see that in both scenarios, element X belongs to at least A or B. So one thing is for sure, that it must belongs to the union of A and B. So if it belongs to the union of A and B, and we started that X is an element of A steric B, and we ended up with the conclusion that X is an element of A union B, which means the X exists in both. And as we took X from A steric B, and we ended up in a new set, A union B, and we got to know that this particular element also belongs in this set as well, which indicates that A steric B is a subset of A union B.